Okay, so this question talks about finding the equation of the diameter which passes through the origin. So we have some circle and we know that the diameter must pass through the center of the circle. So radius, same length, and it looks like it might look something like this going through the origin. So basically we're going to need to find 2 points, the center of the circle and the origin will allow us to find rise on run for this gradient of the line, and that will be the equation of the diameter. So to start with this, we're going to get this into a more common form, the circle equation form that looks like this. And to do that, you've got these perfect squares here, so it looks like we have to complete the square for the x part and the y part. So I'm going to go completing the square. I'm going to halve the coefficient of x to the number in front of the x and square it. So minus 4 divided by 2 is minus 2. You square that and you'll get plus 4. And we subtract minus 4 such that this is the same as this, because I've essentially just added a 0 here. 4 minus 4 is 0. Completing the square for the second one, we're going to get, I won't skip steps, y squared plus 6y plus 9 minus 9. So that's the same expression as this. And then we need to know our perfect squares. So this blue one's going to become x minus 2 squared, and you leave the negative. And this one here is a positive perfect square, so it's going to be y plus 3 squared. Keep the negative. So if you expand this, you're going to get back the blue one. And if you expand this, you're going to get back the yellow one. So that means that the equation of the circle is going to be this. (18 plus 9 is 27. Just make sure I've got that right. 4 plus 9 is 13, plus 14 is 27. Okay, so my radius is root 27, which can be simplified, but I'm not going to do that now. So we can identify the center of this circle now. The center is at 2, negative 3. And that means that we have something that looks like this. 2 across, 3 down is the center. The radius, root 27, is between root 25 and root 36, so it's between 5 and 6, so it's 5 point something. Okay, so minus 3 here, 2 across, it's going to go up like that. It's going to look something like this. Doesn't have to be exact. And then the equation of the diameter is going to be something that looks like that. So the center is 2, -3. That means the equation is, if we do rise and run for a straight line graph, rise on run, going down 3 and across 2, so it's -3 on 2x, and it goes through the origin, so the y-intercept is 0, so that's the equation of the line. And it's not exactly clear if it wants a restricted domain or not. So what I mean by that is, the diameter starts here and stops here. So you might have to find the intersection between the circle and the line to find these 2 points. So you can get x, y, x, y. So this is going to be some positive value x, and this is going to be probably some negative value x. So, we're going to have some restrictions here if I want the diameter just to be that. And I don't know what those values are, but if you use your calculator or you can do it algebraically, y equals -3 on 2x, and the circle x minus 2 squared plus y plus 3 squared is √27 squared. Because I have y equals -3 on 2 on x, I can just substitute this into here. But you got fractions that looks like it's going to be ugly. But if you do that, you're going to get a quadratic equation which you can solve. So expand that out. Make one side equal to 0, and then either factorize or use the quadratic formula to solve for those x values. Okay, and then that's if they want these restricted points. So the diameter strictly being between this x value and this x value, but I'm not exactly sure if they want that from the question. I don't think it's clear enough. Okay, I hope that helps. Now, really, it's just about reading the question and trying to understand what it means. So find the equation of the diameter which passes through the origin. So a quick little sketch will say, okay, so passes through the origin, that's 1 point. Has to go through the center of the circle because it's a diameter. It's not a chord. A chord would look like this, going from 1 point to another, which does not go through the center. So yeah, it's just about reading the question. I hope that helps.